Alright, you guys, let's get going here. Again, I apologize for being out, but it's important that I am. And I will do my best to kind of keep us moving. But I need your commitment here to keep moving forward. I'm going to try and do things that I think we can do with me absent, and will still be productive work towards our goal. Yesterday at the end of class I introduced the b variable, and I want to just reintroduce that a bit today so that you get more comfortable with it. So really today is not new material, but we're just going to go over what we've done before that I introduced at the end of class. So let me just maybe look at these three things here for a minute. This is your generic sine curve. You know its key points, where it begins, its middle, and its end. Max is at 1 and min's at -1. So those are the 5 key points. And the new variable is the b variable. You'll notice it goes in as a multiplier to the angle. And what it does is it changes the expansion or the contraction to the y-axis. So ultimately what it's doing is it's going to take a normal period of time, our normal cycle, our normal 360, and it might make it longer, like 720, or make it shorter, like 90. And all that does is, instead of the normal curvature and normal period length, it comes tighter and it goes much quicker, or it goes much further and it's a much smoother, longer process. Now what makes it a little bit tricky is that our graphs often don't have many degrees in the horizontal. And so often, instead of seeing all of the period, we don't get to see all of the period. But with some of these graphs, I do try and create a little bit more of the horizontal measurements so you can get more in. Well, let me take a look at sine of 1/2 of theta. Again, the way I suggest you remember how this works is that when it says 1/2 of theta, it's referring to that you see 1/2 of the normal period in 360. So if you'll notice here, half of the sine curve, this is the part where it rises and comes back to its middle, is visible up to 360. The other half of it, the lower half, quadrants 3, 4, would then be extended in the next 360. If it said a fourth, it would even be a lesser showing of the graph. It would only be basically the rising part of it, because again, think about each of the quarters, quarter 1, 2, 3, and 4. So a half shows up to here, a quarter shows only that amount. And generally, just for ease, I'm only going to do halves, quarters, times 2, and times 4. That's plenty of good learning with all the other things going on. If we have a number like 2 in that position, it's a multiplier, and it means 2 of them in 2 pi. So there's more of them. You'll notice that that's what happens. And the way I do this is I say, all right, there's 180 to there. I need to see one of them by then, because if you have 2 in 360, then you have 1 in 180. And so what I do is I divide it into its pieces. I create the first one. I divide it into its pieces. I create the next one. And the same goes for cosine, and you just start at different places, but the compressing and expanding is the same. What you will notice that's a little trickier about this variable is 2, even though it's a kind of a multiplier of 2, actually it's the one that does the compressing, and a 1/2, even though it's halving, is actually doing the expanding. So that's why this variable is always the trickier one. It involves kind of an opposite nature to it, an inverse nature to it. So let me just do one of these, and then I'll do maybe 1 or 2 under the Elmo to demonstrate it to you, and then I'll explain kind of what I'd like you to do today. So this means an amplification of 2, so we're going to expand it this way by 2. This means that we're going to see 2 of them in 2 pi. You know what? I'm gonna change this to cosine just so I get a little cosine experience here. Let me just quickly draw cosine to remind you it's what it looks like. So there are its key locations right there. And I'm going to use this to help me get this. Now on your graphs, I always put the parent function down to make your life a little bit easier. And so maybe I'll do the same here. So the cosine function would look like this, basically. So I'm going to amplify it 2 times bigger, and I'm going to also change its period. I think, I've been thinking about this all night, I think it's best if you do B first and then do the A. So change the period, then change the amplification. So this means 2 of them in 2 pi. So I need to see a full cycle here. And so things get compressed. It would look like this. And then it would repeat itself again. Knowing the key points makes this very doable. So do you see the 2 of them? There's the first one and there's the second one in 2 pi. And it allows for me to get the 2 in. So this is taken care of. And then the last stage is to now amplify that 2 times bigger. So this key point gets multiplied by 2 way up here. This one gets multiplied by 2 down here, times 2, times 2, times 2. The 0 points do not get altered. They stay right where they're at. And so my final graph is down and up, and is down and up. Well, that's kind of messy. I get that's difficult for some of you to kind of see correctly. I'll do some up a little bit closer. But the idea is that first I compressed it, and then I expanded it. And then you'll see on the ones you've got to do that there's multiple steps here. Okay? So let me just show you maybe one more example here under the Elmo. So from the worksheet you got the other day, just go to the back side, and I want to just maybe do the first one for you. So actually you only have 7 to do in the 20 minutes to get you going. Here's of course a sine 2 theta plus 3. So I have a b change here. This b of 2 means 2 in 360. So immediately I know that my period length is no longer 360. It's going to be 180 because I have to fit 2 of them into the 360. So what I do initially is alter the B first. Always, I think B first is a great plan. So what I like to do is do the start, middle, and end points first. So in the sine case, it goes up through the middle and then down and then back. And so I know that what will happen, and I'm going to just plot this lightly initially, but there's what that would do. And when I get a period change like that, when it's so small, I think it's always a good habit to maybe do another one, just so you get a sense of what would take place. So there's your 2 sine 2 theta. And now I'm going to adjust it by a plus 3. So everything goes up 3. So 1, 2, 3. And when things move up, I sometimes move the axis of symmetry. It helps me to keep things organized. And so I'm gonna kind of do the same thing I just did down below. There's my first one, and I've got another one here, again plotting my 5 key points. There's my second one. This would be sine 2 theta plus 3. Now the other ones have some mixes and some changes, but be careful with them. There are 2 little errors, and I wasn't watching carefully when I made this worksheet. In the bottom left corner, this theta symbol is missing, so I'll just put it there. But in this question, you're going to amplify it 4 times bigger, and it's going to be a fourth of the entire sine curve in 360. So a fourth, I'll just help you on this one a little bit while I'm here. A fourth means you'll only see kind of that first 1/4 of the curve. So it's actually going to go from 0 up to its maximum at 360. So you're only going to see, oh well, here I go, I'm doing too much already, but you're only going to see this piece. I actually like to do the other side of it too, just so you get a bit of it. But there's only 1/4 of it there, and now apply the scaling of 4 times bigger. The last thing I'll go over here, there was an error here as well. What was it? Oh, I know what it was. Yours says sine here, and it's supposed to say cosine, because obviously if you look closely at the graph, it's no sine curve, it's a cosine curve. So fix this. So off you go. Let's get working. You're going to complete these 7 that I've left you. Then you'll take the transparencies, check your work. And then in the last 15 to 17 minutes, I want you to try 4 problems as if it was a quiz, because I'm going to look at them just to see how well you get this stuff and what I need to continue to help you with as we move forward. Thanks. Let me just give you your quick instructions now for today. For about 20 minutes, I've asked the sub to basically provide you that time to work through the questions that are on the back of the worksheet that you had. I had mentioned in the Elmo the 2 little fixes that I needed you to do. So fix those, make sure they're fixed. And then I want you to work on those. At the end of the 20 minutes or so, the last couple minutes in there, I've asked the sub to hand out the transparencies for you to lay them on top of the ones that you were able to complete and kind of get an assessment as how things are going. And then for the final 17 minutes, I want you to work on the 4 questions that we'll hand out here in a minute. Well, you'll get them at that time, but basically there are 4 questions, and I just want to get a sense of how well this is going. So I want you to skip to this part and just do the 4. Do as much as you can in that time. 4 questions, that's about 4 minutes a question. I think that should be about right. And I'd like to see how much of this you're getting or understanding, so I know how to deal with it on the block day. Thanks, guys. Have a good day.